In this video, we're going to be looking at compound interest. So compound interest is just the amount of money that you would have in a bank account after you invested some money and let it sit there for a certain amount of time. So the first thing we'll need to do is look at our general formula. We have A, the final amount in our bank account, is equal to P, our starting amount in our bank account, times 1 plus R over N, so that's our interest rate written as a decimal, divided by the number of times it's compounded per year, and then we raise that to the n, same as this n right here, times the amount of time, t, that we've invested this money. So the trickiest part probably of this is the number of times compounded per year, because value is going to come from a word. So for instance, if it's compounded monthly, our n would equal 12. If it's compounded quarterly, our n would equal 4. If it's compounded annually, our n would equal 1. So just try to split a year up into how many ever portions the word suggests, and that's what your n will equal. So let's look at an example. Leif wanted to invest. Leif invested $5,000 into a savings account at an annual interest rate of 5%, compounded quarterly. How much will be in Leif's account after 7 years? So we're going to look at our general formula, which is A is equal to P times 1 plus R over N raised to the N times T. So let's see if we can assign all our variables a value. Well, A we know is going to be our question mark. That's what we're looking for. Our P is our $5,000, our starting amount. Our R will be 5%, but we want to write that as a decimal, so it's 0.05. The N comes from how many times it's compounded in a year. So if it's compounded quarterly, our N would equal 4, quarterly splitting a year into 4 parts. And then the amount of time that we are compounding this is 7, for 7 years. Now we just plug all these values in and we solve. So I have A is equal to 5,000 times 1 plus 0.05 divided by 4 raised to the 4 times 7. We use our order of operations as we do this, focusing on what's inside the parentheses first, then moving to exponents, then moving to our final bit of multiplication. So when I look inside my parentheses, I see division, so division will come before addition. So we have A is equal to 5,000 times 1 plus 0.0125 raised to the 4 times 7. So A is equal to 5,000 times 1 plus 1.0125, adding 1 and that together. I can go ahead and multiply these together. 4 times 7 is 28, so it's raised to the 28th power. I'll do my exponent before I multiply. Exponents comes first. So I have A is equal to 5,000 times about 1.42. And then when we finalize this, doing our final multiplication, we have 5,000 times 1.42, and we get 7,100. So there'd be about $7,100 in Leif's account after he let it sit there for 7 years, compounding quarterly with an interest rate of 5%. And that's how we can use the compound interest formulas to help us find out how much money is in an account.